Welcome to Web Handling. My name is Dave Roysum. I am super excited to continue Dave's defect with bulk or thickness loss in wound rolls. This tight defect is common with nonwovens and tissue of many different chemistries, especially where absorbent capacity or insulating properties are important. I know your time is precious, so let's get started. Bulk loss is defined as the radius-dependent loss of bulk, caliper thickness, or some other associated test property that is caused by the web yielding under interlayer pressures inside the wound roll. While thickness itself may be the measure, it is often other properties such as absorbent capacity or insulating R value that is of greater concern to QA and your end-use customer. It is common on a wide variety of thermoplastic nonwovens, such as used in diapers, medical care, personal care, and more. It is common on fiberglass, where insulating properties are lost, as well as possibly fiber damage. Finally, it is ubiquitous on creped tissue and kitchen towels. If you followed the last clip, Web20168d, you would know that bulk loss has no single root cause per se. You would also recognize the factor for this bulk loss problem are almost identical to blocking because the wound roll physics and relevant web properties are quite similar. Now would be a great time to view or review that clip. The well-documented and well-tested 50-year-old science of winding tells us that the pressure inside the roll must be higher at the core, medium in the middle, and zero at the outside. This is true of every wound roll ever wound, for every chemistry wound, for every winder make and model, and for every setting or curve or taper on that winder. In short, it's guaranteed by the laws of physics. If the web is tender and yields under ZD pressures, then it must have more thickness loss at the core, less in the middle, and no loss at the outside. Thus, not only are the desirable properties of absorbent capacity, insulation, or thickness lost, they are uneven throughout the roll. However, as we learned in the advanced winding section of my Web 101 course, pressures come from both winding and the outside world. Both must be considered and ranked. The winding pressures we already outlined. They are highest at the core. However, the core support pressures during winding and unwinding must also be considered. These are also highest at the core. So, how do you know which one is biggest so that you can work the problem most effectively? Simple. Compare the losses at the core when winding a half-size roll with a full-size roll wound under the same tightness. If bulk loss is reduced during that test, then winding is the big deal. If so, reduce all of the TNTs as we covered in the class. However, if the loss near the core of the half-size roll is nearly the same, then support is most important. If so, you should consider bigger diameter cores or smaller diameter rolls. As usual, we do a literature search to see what other information there might be on our defect of interest. Again, we start with the Roysum Library database by Abbott App, perhaps searching under the word bulk or thickness or caliper. Unfortunately, there is very, very little written about this defect, and most of it I wrote myself. You may find some other articles if you search a little harder, but I'm not aware of much of any published work in this area, regardless of what search terms are used. So, we are still guided by science, but the details and sensitivities you must figure out for yourself for your wound roll product. Thank you so very much for joining me in this defect solving and defect preventing series. Stay tuned for the next clip where we discuss one of my favorite defects, contamination. If you found anything interesting or useful here, please like and share and subscribe. Please also consider supporting the work of this channel using the Patreon link below. See you next time.